Most elements have some isotopes and are radioactive. What are meant by the terms? So an isotope is the same element but has a different mass. So elements would be the same number of protons. That's a shorthand for number of protons. And if it's got a different mass, it will have a different number of neutrons. Because neutrons affect the mass, but are chargeless. If something's radioactive, well, it's a substance that gives out radiation. Here we have a graph showing the activity, or the number of plutonium nuclei over a given time. And it wants us to find out the half-life. So it starts at 1,000 plutonium nuclei. Because it's a half-life, we do the half that, which is to 500. Then to find out how long that took, we get our ruler, make sure it's nice and lined up, go across. Missed it there. Then, from that point, go down. So that is 50, 60, 70, 85 years. Oops, sorry, that's 85 years. Just need to make sure, find out how much each one of these is. Then go for each one. This goes to 5. So you've got 55, 65, 75, 85. The Cassini spacecraft was launched in 1997. It took 7 years to reach Saturn. The electricity for powering the instruments on board was generated using the heat from the decay of plutonium. Plutonium decays by emitting alpha particles. What is an alpha particle? Now, it is a helium nucleus. But some people find that hard to remember, so you can just say 2 protons and 2 neutrons. This is the largest of our 3 types of radiation, alpha, beta and gamma. During the 11 years that Cassini will orbit Saturn, the output from the generators will decrease. Explain why. So as we just saw from our graph, the rate of decay decreases. That's because we have less total undecayed nuclei. If we have less decay, then we'll have less heat produced. And even if you don't remember that, it says here on top of the question, heat produced from the decay. So that's where we get our second mark. So you should always look at the information given, because it may give you a hint to your answers. So plutonium-238 is highly dangerous. A tiny amount taken into the body will be enough to kill a human, but it is unlikely to cause any harm if outside the body, but is likely to kill inside. Explain why. Well, we said it releases alpha particles. So alpha particles cannot penetrate the human body because it can't penetrate the skin. So it's highly ionizing, but it is very weakly penetrating. Beta is moderately ionizing and moderately penetrating. Gamma is highly ionizing, but highly penetrating, but very weakly ionizing. So if they're good at ionizing, they're bad at penetrating. If they're good at penetrating, they are weakly ionizing. So that's about the outside of the body, but kill us on the inside. Well, because it's highly ionising, it can kill or damage cells. So when we have alpha radiation, it can damage cells. That's because it is ionising. And this killing or damaging cells can cause mutations in the DNA and conditions such as cancer. In 1964, a satellite powered by plutonium-238 was destroyed and caused the release of radioactive materials into the atmosphere, suggested by some environmental groups protested against the launch of Cassini. Well, in 1964, it blew up and released radioactive material. That happened once, so they'd be worried it could happen again. You could also have that if it did happen, there might be a negative effect on people. There could be a release of radioactive materials. That if there was an accident, it could spread radiation over a large area. So any sensible suggestion would be useful here.